Hello, today we will discuss the peer graded assignment of the course Machine Learning for Product Managers. We have been given a data set, so I have it open here in VS Code. The data we have is of different temperatures, ambient pressures, relative humidities, and exhaust vacuums, and the output or the Y value is the energy output, right? So we have this data sheet here. So if you're curious, combined cycle power plant, you can Google and see General Electric builds these. So yeah, it's an interesting hardware. So I've imported the data on a Google Sheet and I will walk you through the steps I've taken. So first of all, I've renamed the different, the first row so that it's a bit more easy to read. And of course, we have the output. And I also needed to format the number, format all the cells into numbers. You can do that easily via a group command. And overall, we have different values of x1, x2, x3, x4, and y. Okay. My first goal was to find which column or which field, which feature aligns the best with our desired output or y. Okay, so I have created graphs of x1 minus y, x2 minus y, x3 minus y, and x4 minus y. We have four features, x1, x2, x3, x4, and for each I have prepared a graph versus y or the desired output, right? These are the graphs. I'll go through one by one. For example, this is energy output versus temperature. So if we go to the customization and go to series, then I have plotted this. This is, by the way, a scatter chart. All of these are scattered charts. If I go to customization, I have then drawn a trend line and I have used different types of regression methods. You can use linear, and as you can see, the R square value changes, right? So for this is 0.899. For exponential, it's 902. For polynomial, it's 912. For logarithmic, it's 875. So we can see, and the others I have also checked. So for polynomial, and if we update the degree from 2 to 3, we get the best fit. Okay, we get the best fit. So accordingly, I have checked the R square of the other features. So this is versus temperature. This is versus exhaust vacuum. This is versus ambient pressure. And this is versus relative humidity. As you can see, the R square value for the other features are very low. So for relative humidity, it's only 0.154. For ambient pressure, it's only 0.298. And as we know, the closer we get to 1, the better. Again, for exhaust vacuum, it's only 0.775, which is very low. Compared to that, if we compare versus temperature, as you can see, it's a very good value. It's 0.912. The trend line for temperature, the R square value is 0.912. So we can conclude that the best way to predict energy output is to focus on the temperature. As the temperature increases, it seems like the energy output is low, and as the temperature decreases, the lower the temperature, we seem to have more energy output. And if you want an equation for that, this is the equation that I got from this diagram. You can get it quite easily, actually. I'll show you. We go to edit chart from the customization series. You can just visualize the equation right here. So I've copied it into its separate field so that it's easy. So now whenever a new energy output we need to figure out, all we need to do is capture the temperature. We need to feed it into this equation and we will get an output which shows us how much energy output in megawatts we can expect. Thank you. Please leave your feedback, and yeah, thank you.